Okay, welcome to the second lesson, Introduction to Python 2. We're going to get started with functions. And so functions are a way to reuse code. So the way you define a function is using the def keyword, and you're defining, in this case, a calc underscore fv function, and your input parameters are pv, I, and n, right? Then you can put a doc string here. This is called a doc string with the three double quotes to begin and end it. And that, kind of you summarize your function and the inputs and the outputs and what it does. This is pretty straightforward. We are just calculating future value here with the given inputs. So let's define it, and then we run the function with these arguments. These are called arguments that are passed to the parameters. And so one thing I want to point out is uh, the scoping of PV and I. Now here we haven't defined PV. Um, it's outside of the cell or outside of the function, so it's not going to be available. A little bit further on, we'll get into classes where um, you could actually put variables and functions together into a class, and then we could grab certain arguments out of it. But in functions, you're not going to be able to go into the scope of the variable outside of the function. Uh, so we note that the three quotes is a doc string, which is an optional type of comment. But it's useful with Jupyter notebooks because you can use this question mark, um, and it'll output the doc string for you, the signature, and where the file is, and the type of the function. And if you do two question marks, it will give you the entire code, which is very useful. This is for functions that you wrote and that you've imported that you haven't written. Um, so it's useful documentation there. So there's a lot more that goes on with functions, but that's just a very uh, cursory review of them, introduction to them. Now, with classes, that is when you need logic and data together. Uh, and so here's, you use the class keyword to define, so here we're defining a zero bond. Uh, and this is a special type of function, or this is a special method, which is initializing. What's going to happen when you first call this? And you see there's a self keyword there. That's always at the beginning of the initialize function or any method um, within the class, and that's a special keyword that allows it to refer to itself. So what we're doing here is the parameters that are passed to, that are the arguments that are passed to it, we're going to save that into these these are called attributes of the class or of the object when we define it. And so we have one method called price, which is going to price it out. This is zero bond, and uh, let's go ahead and run this and we initialize a zero bond here, and now we're going to call the price method of that, and then it's going to return the price of the bond. Now the cool part about this is you have access to uh, the value, the initial value, bond. You have access to all the attributes of it that you pass to it, because that's what we define. So let's see. The next section is probability. Oh, I forgot to mention that we do have this table of contents view here, and so these are just all the sections that we're going through. So next, it's probability. So Python has a random module that we can take a look at. Um, it has a few different functions that you can review, but you know, you can create a coin based off of these. It's really a list here that we're creating, heads and tails, and we're gonna make a random choice of that list, and it will return tails. But if you run it again, eventually it'll return heads, and it's random. It's a random choice. Um, and so you can also do part of this module has the rand_int function, and that will select a random integer between the start and the um, end of the integer. So we can go ahead and check out rand_int, return a random integer n such that a is less than or equal to n, less than or equal to b. And so uh, that's part of the random method, or the random module. So we have combinations and permutations in probability, and in Python 3.8, those functions are going to get added to the math library, but at the moment they are implemented. We can look at the SciPy library instead, and we can go ahead and look at what the combination it says the number of combinations of n things taken k at n times. This is often expressed as an n choose k. So we have we can run that and we get 15 combinations. We also have permutations where order does matter, and so in permutations you should have 30 when you have 6 choose 2. So that is a bit of probability. And for statistics, there's also a statistics module as part of the Python standard library, and it's got a few functions: mean, median, and mode, as well as like specific median functions, variance, and standard deviation functions as well. And usually this data is typically a list that these functions work with. So we have here's a heights list. We can find the mean of that list, the median, mode, the population standard deviation, and the population variance, as opposed to the sample variance. And so these are topics that come up in CFA. So it's good to go through them both in the materials, but also in what's available, already out of the box with Python. So dates and datetime. It's very important in the finance, in a finance context, financial data, time series data. It's it's all indexed by time. So there's a few date times that we're gonna cover. The first one is the Python, the standard Python one, and so this one's a little odd because the class and the module, it's called the same thing. So this way, from the module datetime, you're importing datetime. And so we can take a look at the docstring here, and it says it's a year, month, and day is what you pass to it. And so here's how we just create uh, November 1st, 2019. Now you have a date, a variable of that. So that's the first date. You could also grab today's date uh, and, sorry, the date time. So you need to make sure that you keep track between date times and dates. So date times include the hour, minute, second piece, but dates do not. Um, so the dot now is what gives you the date time, and the dot today. Um, oh, sorry, dot today dot date would give you the date return, and those are two different objects, and you'll see that um, when we move into some other libraries, it's important to know whether we're using going back and forth, translating between date times and dates, keeping that in track. But there's also the pandas date time or timestamp that we'll look at, as well as some others. But for date utilities, okay, so how do you also start to do, data arithmetic? So we can import something called the relative delta from the date util library package. And so this can create a delta. You can figure out the difference between two dates. So the different in, it's 8 days between the first date here and 11 November 1st and December 9th. And that's just the days difference, but it's also a month as well. This is the full difference between it. So months as well. Yep, so it's 1 month, 8 days between these 2 days. And you can see that's negative, so there is a sense between what the start and end date are, the direction. But you could also add this delta to a different date. So that's going to roll back this October 1st day to 8/23. We can also convert from a date. You can convert back and forth between string representation and date representations. So here's string formatted to time. So we're taking the date and it's returning just this the string version. Now here's a reference that I've added that tells you what the format is of like capital Y, lowercase m, and lowercase d. Different formats and different types require different codes input into here, into the stringf_time function. We can do the reverse of that using a parser. And so this is converting, string into a date. And so that is for the date section. For input and output. So this is kind of just if you were to have a program or a script that required data from the user that's running it right away, you could put in put in your age here, and now you've saved age in as a string. Now you need to be careful because that came in as a string because it has the quotes. So what we can do is we can convert age into a number. And so you just need to be careful that this is returning a string type into the input of what you're asking. from this function. Now, file input and output. So in this repository that I've created, there is a data folder, and so so with file input and output, it's also nice to know about where you currently are. So you can use the OS module and run this get current working directory. I think and for Jupyter Notebooks, there's this nice feature that if you hit tab, you don't exactly remember the name, it will get you, it'll kind of do a search on all the functions and classes and modules available in that module. So we're going to grab the first one, and here we are. We are at this level right now. And that's important to know because you need to know, so when you're using file input and output, you need to know where Python thinks it is, and then you can do relative paths according to where it actually is. Now you see, I'm on a Windows operating system, and so this has the backslashes. But I'm inputting in forward slashes that is more common in like Unix-based systems. And the reason I can do that is because I'm using this path module. It'll figure out what operating system I'm using and put together the correct path for it. And so now we can read in some data using this context here. And so this with opening this whatever happens here as f, and we're calling the read function, and then we're storing it into read data, and then we're closing out this this context or this connection. And so this with is kind of important when you're connecting to databases or files or outside, so that you don't create a memory leak, because it'll kind of open the connection to the file and then close it, so it's not holding on to it anymore. And so now you have read data. Now read data, sometimes these / new lines just appear as text. So it's reading in the entire file, and so we need to just be aware of that. And so you can also read this a different way, which is reading it line by line. So here we're reading the same file, but we're only reading the first line, right? And that first line does have a new line character at the end with \n. And so here is, sorry, this is just the same thing. Yep, so that's file IO. Now you could combine this with like a for loop, or any other, and like read all the data in this, and that might be an assignment. So keep in mind on how to do this in combination with some of the previous lessons. Okay, so JSON is a data format that is very common when different systems are talking to each other. They typically use JSON because it's like language agnostic. So I could have like a web. You could, if we're connecting to Fred, and their system is written in Java, but I'm connecting it with Python. The data is gonna be, if the data is JSON, it doesn't matter. Both have libraries to allow you to understand that data. So it's just good to know that JSON data gets turned into a dictionary in Python when using the JSON module. And it's we talked about dictionaries, but this is kind of a nested dictionary as well, which is possible. And what I mean by that is that you'll have a key, but the value of that key is yet another dictionary. And you could have this go on for as long as you have space, infinite amount of times, right? There might be some soft cutoff, but I'm not sure. And so here we're going into the glossary key, and you see that this is yet another dictionary. We could keep doing that based on JSON. It's common to have nested data structures like this. Sometimes if they have integers and floats, those can be automatically converted, like the JSON module would automatically convert you that to the right data type if it's supported in JSON. If not, it will just leave it as a string. And then finally, yeah, so how we talked about that, there's another format called XML that is similar to JSON. It's kind of an older format, but it's still commonly used. And so here's how, for example, data.treasury.gov uses XML data. And so it's not the most user-friendly. You do need to bring in this other standard, part of the standard library called XML module to deal with it, and it's quite nested. There's this list of elements. We are grabbing yield curve rate data for different terms, and then you do eventually can get to, so you could probably write a program. I mean, this is a parser already. You could write on top of that specific logic to parse this out further, but we'll see that there are other people have written APIs that or libraries that are, it's easier to get this data into a data frame from pandas, which we'll talk about. So I think I'll finish this lesson here and then move on to the next lesson. Thanks.